The atmosphere is a very important component of the Earth system. It's important because it protects us from cosmic rays, but also because it protects us from other forms of radiation and serves as a regulator for temperature on the planet. So life as we know it is possible on Earth because of the presence of the atmosphere. The atmosphere is extremely important, and it's extremely important also to study its characteristics and observe it from space. The atmosphere is 99% oxygen and nitrogen, and this is what we breathe in. But at the same time, there are also gases and particulates that are quite important. For example, in the atmosphere we have CO2, which is a very important greenhouse gas. We have ozone, which is extremely important to regulate the amount of ultraviolet radiation that we receive. And then we have other compounds, for example, so-called aerosols, that are also important in the climate system because they regulate the amount of radiation that we receive from the sun, interact with that radiation, serve as cloud-forming particles, and also they regulate the amount of radiation that is emitted and that gets back out to space from the Earth's surface. So all these tiny particles and gases, so-called trace gases, are extremely important for the climate. These gases cannot be observed, with naked eye. You need special sensors that can measure at different so-called wavelengths, and they can infer information about trace gases from the radiation. So we don't directly measure the presence of these gases or the amounts, but indirectly we can find their signatures in the electromagnetic radiation that is emitted by the Earth and that has to travel through the atmosphere to reach the satellite. So the view from space is extremely important, and in fact a lot of things were discovered, enabled by satellite observations, because we couldn't really see them from down below. So the view from above is very important, and it has been instrumental to the development of Earth monitoring and modeling in the general sense. There are several techniques from a satellite that could be applied to viewing the atmosphere. There is the so-called nadir view, in which the satellite looks directly what's below and just observes what comes out of the Earth atmosphere. There is the so-called limb view, in which the satellite observes from a side. And those are important techniques because one enables more horizontal resolution, and that is the nadir view. You can really look at high resolution, but you don't have vertical information because you sense the total column in the atmosphere. But the limb sounding view, on the contrary, allows you to especially sense the higher levels of the atmosphere, the stratosphere, for example, and also get vertical information because you can dissecting the atmosphere and cut it into different levels, and then you get the information from the various levels. So both are extremely important. The horizontal resolution is more coarse, but still you get the vertical information, which is extremely important. So aerosols are interactive with the radiation that comes from the sun to the Earth, and then also with the radiation that comes from the Earth and is emitted back to space. And because of this, it's possible to sense them from satellites, because satellites sense the radiation. And then you can infer properties about the aerosols through analysis of this radiation that the satellite has sensed. And that is extremely important in my job, which is that of predicting the aerosol state with few days ahead. And I use the satellite information, the observations derived from the satellite, to initialize the model and constrain the model so that the prediction is as accurate as possible or as close as possible to current observations of the state of the aerosols in the atmospheres. And a similar thing is applied to other trace gases, ozone, carbon monoxide, as well as observing wildfires and emissions of carbon dioxide and biomass burning from fire. So it's the same principle. Some instruments, for example, the so-called imagers, they look at the refracted solar radiation and they sense mainly clouds, aerosols. They can give information about surface characteristics, surface albedo. Then you have a set of sensors, still passive sensors, that instead measure the temperature of the planet because they sense the emitted radiation but in the infrared spectrum. So this is not the visible part but the infrared part.